everybody. So today we're going to go over the notes for section 1.5, which is angle relationships. Okay, the first term is going to be adjacent. So adjacent angles. So you should probably already know what adjacent means. Adjacent, it literally means next to, right? But I'm going to give you the by the book definition of these things. So it might be a little wordy, but it is what it is. Okay, so let me zoom in here a little bit so you can see a little better. So adjacent angles, angles that lie, actually let's write on top of this so it looks better, there we go. Angles that lie in the same plane have a common vertex and a common side but no common interior points. No common interior points. Okay, it sounds complicated, but it really isn't, so check this out. Here we go. Okay, so let's put some letters here. We're going to have L, B, C, R. So we're going to say angle LBC, which is this angle here. Right? Angle LBC is adjacent to this angle right here, which is BRC. So this one, it's adjacent to that one. They're adjacent. They're next to each other. They share a common side, right, to angle BRC. Okay, so same vertex, shares common side, boom. Complementary angles. Okay, complementary angles. Two angles with measures that have a sum of 90 degrees. Okay, so for example, let's say we have something like this. Okay, so we know this is a straight angle here, so if this is 90, that means these two have to add up to 90. So we'll call this angle, let's do something similar. We'll go with DTVR. So angle RDV, this one right here. So angle RDV is complementary. My notation, that's going to be complementary, sorry, I ran out of room there. So angle RDV is complementary to angle VDT. Angle VDT. So we know these have to add up to 90, and we know that, well, that's basically because we know this is 90, that means this other half has to be 90, and guess what? They're going to add up to 90. There you go. Supplementary angles. Two angles with measures that have a sum of 180 degrees. Okay, so let's make a straight angle here. All right, and there we go. So we're going to go with some letters here. A, L, G, R. So we know this is a straight angle here, okay? We know that these two angles would have to add up to 180 degrees. So ALG, I should have put the L down there. Angle ALG is supplementary, and we'll put some notation here, supplementary to angle GL, call that R, GLR. Okay. Okay. Vertical angles, here we go. Two non-adjacent angles formed by intersecting lines. Should probably slide over a little bit more vertical. Intersecting lines. Okay. So what does that look like? Well, we have two intersecting lines, right? Here we go. And they're going to be non-adjacent, so it could be either these two or those two. So we'll just use these two. So that angle and that angle. And vertical angles are actually always going to be congruent to one another, by the way, which we'll get to in a bit. But yeah, vertical angles are always going to be congruent. And you'll be using that too. Linear pair. Linear pair is a pair, who knew? A pair of adjacent angles with non-common, that's not an M, geez, what was that? Non-common sides that are opposite rays. It's funny when you read these definitions, it sounds so bizarre, because when I show you the picture, it's not going to be how you would define it. Not that the definition's wrong, it's not wrong at all, but when you see it, you're going to think of it a different way. Watch. This is a good example of that, I think, at least. So we have a straight angle here. We have a ray coming out of it. Therefore, this pair is a linear pair because it forms, guess what? It forms a straight angle. So think of a line. A ray comes out of it. The resulting pair of angles has to be a linear pair. Pair that forms a line, linear, right? Line, think of it that way. It's a pair formed by a line, right? Anyway, oh, lights just went out. There we go. Okay, angle addition statement. Okay, so angle addition statement. I want to draw the example first and then write the definition because I think for this one it would make more sense. So I'm going to draw an angle here. So we're going to go here, and we're going to say that this is angle PQS. PQS. And we're going to have a ray coming out of it. We're going to call that, oh, I don't know, call that D. And basically what the angle addition statement is telling us is that when you have a larger angle, right, and there's a ray that kind of splits into two separate angles, these two separate angles will add up to the larger angle. So for example, PQ, I'm going to just put it over here actually as an example. PQD, so angle PQD plus angle QDS, sorry, DQS equals, this should be the measure, yeah, this should be the measure of, I apologize, this is the proper notation, Brian. Measure of angle, and the big angle, PQS. So this is basically, this is showing us algebraically what this means. It's telling us that these two smaller angles add up to the larger angle, measure-wise. And I think that makes sense, right? It's the idea that you can add these angles to, it's actually very similar to the segment addition postulate, which we used before, right? The segment addition postulate for, what was it, section 1.2, I think it was, where you have the larger segment, two smaller segments that add up to it. It's identical, almost identical. It's very similar to it. Okay? So anyway, this is these are the terms we're going to be using in this section. This is the last section before we start the unit review, which will be later this week, and we will be testing next week. So we had a quiz last week. We're going to have a test next week. I was planning on this week, but I just don't think we'll have enough time this week to get ready for it. So anyway, let's go through the examples. So down here at the bottom, let me zoom in because this text is very, very, very small for some reason. Okay, find the measure of an angle complementary to 37 degrees. So complementary means it adds up to 90 degrees. So we're going to call the unknown angle, I don't know, x, I guess. So x plus 37 equals 90. And we're going to solve for x, so we're going to subtract 37 from both sides. X will be equal to 53, I think. That sounds about right. 53, yep. 53 degrees. And then the next one. Find the measure of an angle supplementary to 153 degrees. So similar, only instead of 90, it's going to be 180 degrees. So again, we'll call it x. So x plus 153 degrees equals 180 degrees. Solve for x. We're going to subtract 153 from both sides. Oopsie. There we go. And then x will be equal to what, 27? Sound right? And yep, 27 degrees. There we go. All right, so yeah, that's how you use supplementary and complementary. Let's see what we got in the back here. So, okay, I'm not going to do all of these. We'll do all of these. I'll do all of them, whatever. I'm feeling generous today. So, name the relationship that exists here. So we have complementary, linear pair, vertical, or adjacent. All right, I'm going to zoom in a little closer here so you guys can see a little better. All right, so these two are formed by intersecting lines. Okay? Vertical. There. And you can also think of verticals across from each other. That's kind of another way to, in shorthand, to think about it. Here, so the options are complementary. Nope. Linear pair. Yes. Definitely a linear pair here because it's forming a straight angle. Vertical, nope. Adjacent, yes. It's actually both. Although, if it's a linear pair, they have to be adjacent, so I guess you could just put linear pair and it would be assumed that it's adjacent as well, but we're going to put both. Why not? Okay, number 4. We got, ooh, this is interesting. This is going to be 2 of them as well. So this is a right angle, which means these two have to add up to 90, which means they are complementary. And again, we know, well, actually it doesn't have to be. So we're going to put adjacent as well because they are adjacent. They're next to each other and they share a common side. Okay, this one. We don't know if they're complementary. It looks like they are. Well, not really. It doesn't look like they are. But there's not enough notation to tell us anyway. But they are adjacent. Let me zoom out so you can see all of them. And that's that. Okay, let's look at the next view. All right, we got find the measure of angle B. So zoom in a little further. So this is a straight angle here. These are supplementary. Therefore, these have to add up to 180 degrees. So B plus 155 degrees equals 180 degrees. We just solve it algebraically, so we're going to subtract 155 from both sides. And B will be equal to 25. So yeah, 125 degrees. Cool. Let's go down to 9 here. So these are vertical angles because they are formed by intersecting lines. Therefore, they are the same. So therefore, B would be 78 degrees because they are congruent to one another. Okay. Number 8, right angle. These are going to be complementary. So B plus 49 equals 90. And then subtract 49 from both sides. That looks like a 1. There we go. B will be equal to 41 degrees. Yep, 41 degrees. And then down here, this is a linear pair. So they should add up to 180 degrees. So B plus 47 equals 180 degrees. And then solve it algebraically. So 100 minus 47. What's that, 133? Yeah, 133 degrees. That's B. There we go. We'll zoom out so you can see all those. Okay. So you're going to be doing problems like this in the exercises I posted. I posted 2 worksheets, so that's why I have no problem trying to do all these, because that'll help you, obviously. All right, and the last 2. Find the value of x. Okay, we're going to solve this algebraically. We're given a pair of angles that are complementary. They form a right angle. So we know that this plus this will equal 90 degrees. So let's make that an algebraic equation. So 2x plus 30 equals 90 degrees. Then we just solve this. So we're going to get rid of our constant. We're going to subtract 30 from both sides. Okay, that's going to be 2x equals 60. Divide both sides by our coefficient here, which is 2. And x will be equal to 30. There you go, I guess degrees. Yeah. And that makes sense because 2 times 30 is 60. 60 plus 30 is 90. That works out. Okay, last one. And then we're done here. So we got, oh, can you read that? I can't read that. There we go. So these angles are supplementary. They form a linear pair. So we know that this plus this would equal 180 because it's a straight angle. So 2x plus 1 plus 79 degrees equals 180 degrees. And just solve this algebraically. Let's combine like terms. So 1 plus 79 is 80. So 2x plus 80 equals 180. Then we're going to subtract 80 from both sides. And that's going to give us 2x equals 100. And divide both sides by 2, which are coefficient, and x will be equal to 50. There we go. All right, so oh, that's a terrible circle. There we go. Okay, so that is going to be it for the the 1.5 angle relationship notes. So hopefully that was helpful for you guys. And the 2 exercise sheets that I put on Google Classroom, so they look like this. I'll show you. This is the second one. The first one's over there, but this is the second one. You're going to be answering questions using the notes. Number 8 got cut off a little bit, just so you know. So you might have to scroll a little bit. But yeah. Actually, I don't know if 8. You might have to skip 8. It looks like 8. Yeah, you probably want to skip 8. Anyway. All right, let me know if you have any questions on this. This is the last section of Unit 1, and then we'll start the unit review this week, and then we'll test next week. So, all right, thanks, guys. Good luck.